Hey guys, what's up? This is going to be the second lecture of Amine where I'll be, helping you out there to find out the structure of the amines, their types, and what are the relationship between the common name and the little bit of IUPAC name. Then I will do a separate lecture on the IUPAC nomenclature, right? So this time I'm talking about mainly structure and its types. So what is the structure here? An amine has, basically ammonia has a structure of this kind. So ammonia has a structure of this kind. So this is the structure of ammonia where there is a lone pair here. Now what you see that the hybridization is sp3. Hybridization is sp3. In case you do not know why the hybridization is coming out, let me help you out with this one. There are 3 sigma bond and a lone pair. So what that mean? There are number of hybrid orbitals equal to 4. So it has 4 hybrid orbitals. What that mean? That nitrogen is using 4 hybrid orbitals to make that structure possible. So that's why the hybridization is sp3, right? What second thing is that what second thing about I'm talking is its geometry. So pyramidal. Why is pyramidal? Because there are 3 bond pair and a lone pair, and you do know that structure mainly depends on the bond pair, the bond pair around the central atom. So lone pair only decrease the bond angle, and overall structure mainly is based on the bond pair. So the structure of ammonia is pyramidal. The third very important thing about this one is that because of the lone pair here, the angle, the bond angle between two hydrogen atoms are equal to 108 degree. What that mean? And it is less than tetrahedral angle. It is less than tetrahedral. Now in case you do not know what this tetrahedral is, then let me help you out. A tetrahedral angle is basically 109 point maybe 28 or something, I hardly remember. So this is the angle of tetrahedral, while 108 is the actual angle of these any of these angles. So this is your 108 degree. Now third very important thing about ammonia is that ammonia is a basic substance. Why it's a basic substance? It is basic. Why? Due to presence of lone pair. Due to presence of lone pair. So because it has a lone pair, so it acts as a Lewis base here. Okay. Though this seems to be information about ammonia, but all these are applicable with the amines also, because an amine is nothing but an organic compound where hydrogens are replaced by alkyl or aryl group. So this was about the structure. Now let me take you through the structure of ammonia. It's something like this. Their central atom is like this, and hydrogen is here. So this is the first bond, right? In case you remember, this is going to be the second one here. This is going to be the second one, and then this is going to be the third one, and there is a lone pair. So this is the orbital structure of the ammonia. Orbital structure of ammonia, right? The type of amines, types of amine. You know that this is going to be 1 degree amine. This is going to be 1 degree amine, and if you have something like this one, where 2 alkyl groups are there, this is your 2 degree amine. Why it's 2 degree? Because nitrogen is bonded to 2 alkyl chain, and similarly this may be tertiary also. So this is your 3 degree amine. Right? Now if you consider like C6H5, maybe a structure of this kind, right? Now let's consider here. This is again, 1 degree amine, but this is called aryl amine. This is called aryl amine. Right? So these are, definitely the types of amine. But if you see, let me take another example here. If you have something like this one, something like this one, this is going to be a, secondary amine. So this is again a 2 degree amine. 2 degree amine. There is a very simple relationship between common name and IUPAC name. Suppose I am taking an example like RNS2. RNS2. So this is called, its common name is going to be common name. This is going to be alkyl amine. Alkyl amine. What about the IUPAC name? What about the IUPAC name? So IUPAC name is going to be, first alkane. Now you don't need E. So what you have to do, remove E. Alkane, and then, it's amine. Alkane plus amine. So they make it a bit more clear. So it's alkane plus amine. So this is the IUPAC name. Now, take an example. Suppose you have this compound as an amine. So it's going to be methylamine. It's going to be methylamine. But when you consider the IUPAC name, this is going to be methane and amine. So this will be methanamine. Methanamine. Right? So this is, how you can do the naming here. Let me do one more. This is, a very important compound. It's called, common name, it's called aniline. It's called aniline. But IUPAC, sometimes is also used as aniline. However, it is not the IUPAC name. So what is the IUPAC name? IUPAC name is going to be benzene amine. Benzene, you have to remove E, benzene amine. So this is what the relation is between the common name and IUPAC name. So a common name consists of alkyl group and then amine, but an IUPAC name consists of alkane plus amine. So if you follow the rule, you definitely will understand. But if you still have problem understanding everything I just said, then about the nomenclature, you can check out the tomorrow's lecture where I will be, helping you out with the nomenclature of the amine. So I hope you have, understand exactly about the structure and its geometry, its hybridization, and also the relationship between the common name and IUPAC name. So thanks for watching, and don't forget to come back tomorrow.